So what we're going to do today, I am going to show you some special angles. Those special angles, I'm going to do 30 degrees, 60 degrees, and 45 degrees. What I'm going to show you is why they are what they are, and you really just have to know what they are, okay? So I know this sounds weird, but the most important part about that I want you to know after watching this video is what's going to be inside of these charts, okay? So I'm going to show you why the sine of 30 degrees is what it is, why the cosine of 60 degrees is what it is. Same thing with tangent. And then all that I'm going to ask you to do is to know them. Okay, so try to follow along as I go through it, but if you end up getting a little lost, don't panic about it. What's really important is that you just know what the sine of 30 degrees is and what the sine of 60 and so on and so forth. Okay, so let's just talk about 30 and 60 degrees. So for me to show you that, we're going to start off with an equilateral triangle, ABC, and the length of AB is 1. So an equilateral triangle is when all of the sides of the triangle are the same, which means that all of the angles also have to be the same. So if this is 1, if AB is 1, that means that AC is 1 and BC is 1. And then also, if all of the angles have to be the same, the angles of any triangle, the angles of a triangle have to add to be up to 180. So if you do 180 divided by 3, that tells you that everything is 60 degrees. 60, 60, and 60. Okay? Now, whenever we're talking about sine, cosine, and tangent, that's right triangle trig. A right triangle has a right angle. I do not have a right triangle. I do not have a right angle in this triangle. So we're going to make one. And what we're going to do to make that is we're going to drop an altitude coming from A. So we're going to draw a line coming from A, intersecting BC. Okay, it's going to be perpendicular, meaning that it makes a right angle. Okay, so I'm going to drop down an altitude, do that in blue, that goes straight down here. Okay, so now I have these as my right angles. So really, we're just going to be looking at this triangle right here. Okay, so I have my right angle in the bottom left. This is 60 degrees. And again, all of the angles have to add up to be 180. So if I have 90 and I have 60, up here has to be 30. I'm going to redraw this in a second too, so that way you can see everything. The other thing that's important is this piece right here. The altitude cut that piece in half. So we went from the whole length of BC being 1 to now this being a half. This is still 1. I haven't touched this. Okay. And now the length of, we'll make this point D, I guess. The length of AD, I don't know. Okay, you have to actually do some work to find the length of AD. So if you remember back from geometry, something called the Pythagorean theorem, a squared plus b squared equals c squared, right? Or leg squared plus leg squared equals hypotenuse squared. So if I look on my triangle, we're going to call the side I'm looking for, we'll call that x. That's a leg. The one that's important is that c is the hypotenuse, and the hypotenuse is across from the right angle. So c is going to be 1. We'll make a and b, doesn't matter which one is which. But your legs of that triangle in blue are the x and the 1/2. So we'll say x squared plus 1/2 squared equals 1 squared. And then we're going to use this to find the length of that side. When this is done, I'm going to redraw this triangle, only the triangle in blue, that way there's not as much going on, you can see a little bit better. So this is now x squared plus 1/2 squared is 1/4 equals 1 squared is 1. Subtract the 1/4. 1 minus 1/4 is 3/4. And then you take the square root. So x is equal to the square root of 3 divided by the square root of 4. Square root of 4 is 2. Square root of 3 you can't do anything with. So instead of writing this as x, x is going to be the square root of 3 over 2. Okay, so let me redraw this triangle for you so it's not as busy. So we have this piece here. This is your right angle. This is 1. This is 1/2. And this is the square root of 3 over 2. Those are all my sides. This angle down here is 60 degrees. This angle up here is 30 degrees. Okay, so you have all of your angles and all of your sides of the triangle. Perfect. So now you can use this to figure out sine, cosine, and tangent for both the 30 degrees and the 60 degrees. So why don't we do 30 degrees first? So sine of 30 degrees. Sine, if this is the angle we're talking about, right? Sine is opposite over hypotenuse. So opposite the 30 degrees is the 1/2 over the hypotenuse is 1. Anything divided by 1 is itself. So the sine of 30 degrees is 1/2. Okay, so maybe you understand a little bit more of what we're going to be doing right now. I'm going to show you why the sine of 30 degrees is what it is, and I just ask that you know what it is. Okay, so if you were in your calculator and you did sine of 30, it'll give you 0.5 or 1/2. Let's do the same thing now for cosine. So cosine of 30, cosine is adjacent over hypotenuse. Adjacent to 30 degrees or next to 30 degrees is the square root of 3 over 2. Divided by the hypotenuse is 1. Anything divided by 1 is itself. So the cosine of 30 degrees is the square root of 3 over 2. Now we're going to do the same thing for tangent. Tangent is opposite over adjacent. So opposite 30 degrees is 1/2 over the adjacent is the square root of 3 over 2. So this actually is a little messy. Whenever you are dividing fractions, there's a phrase that we use. That phrase would be keep, change, flip. So you keep the top fraction, change the division to multiplication, and you flip the bottom fraction. And then you multiply across, you get 2 divided by 2 square root 3. The 2's will cancel, so you get 1 divided by the square root of 3. Tangent of 30, me showing you it as the most amount of work, I promise. So now the other thing, though, is that the square root of 3 can't be in the denominator. Right? You can't have a radical in the bottom. We have to rationalize it. So you multiply the top and the bottom by the radical. We did this a few months ago. 1 times the square root of 3 is the square root of 3. Divided by the square root of 3 times the square root of 3 is 3. Okay? So the tangent of 30 degrees, again, I know it was very messy getting there. The tangent of 30 degrees is the square root of 3 divided by 3. So that's going to come down here. Okay? Now we're going to do the same thing, but we're going to do that with 60 degrees. Okay? So I'm going to clear out what I have in red, and I'm going to highlight and use blue. That way we can make sure we're looking at 60 degrees instead. Okay, so 60 degrees, again, I'm going to like highlight the angle in blue here. So we're going to do sine of 60. So sine is opposite over hypotenuse. The side that's opposite the 60 degrees is the square root of 3 over 2. Divided by the hypotenuse is still 1. Anything divided by 1 is itself. So the sine of 60 degrees is the square root of 3 over 2. Cosine of 60 degrees Cosine is adjacent over hypotenuse. Adjacent to 60 is 1/2. Divided by the hypotenuse is 1. Anything divided by 1 is itself. Cosine of 60 is 1/2. And now the tangent of 60 tangent is opposite, so rad 3/2, divided by adjacent, 1/2. We have to clean this up again though. It's not as bad as the last one, I promise. So again, whenever you're dividing fractions, you do keep, change, flip. So keep the rad 3/2, change the division to multiplication, and flip the bottom fraction. So 1/2 becomes 2/1. Then you multiply across, you get 2 rad 3/2. Your 2's will cancel, and you get just the square root of 3. If your square root is not in the denominator, it's totally fine. So the tangent of 60 degrees is the square root of 3. Again, if that was like super, super messy, that's totally okay. I just wanted you to follow it a little bit, and then you should be memorizing this chart. All right? Now for 45 degrees. So 45 degrees, you have to have a right isosceles triangle, ABC, and AB is length 1. So AB is length 1. A right isosceles triangle means it has a right angle, so that's good for our sine, cosine, tangent stuff. And then also isosceles means that 2 of the sides are the same. Those 2 sides are the 2 legs. In this case, it would be AC and BC. So these are the same. We don't know what they are, but we can use Pythagorean theorem in a second to figure that out. So now the other thing, you might remember your teacher from geometry or even your Regents exam, the sides that are the same, they have the matching lines. So if BC had 2 lines on it, that meant it was a different length. Because AC and BC are the same length, that means that the angles also have to be the same that are opposite them. So that means that this angle here and this one here also have to be the same. Because they all have to add up to be 180, what you would do is, you might even remember just what it is, but 180 minus the right angle is 90. Okay, so you have an extra 90 degrees between angle A and angle B. Because they have to be the same, you would do 90 divided by 2, and you would get that each of these angles, I'm going to erase, each of these angles are 45 degrees. This is 45, and this is 45 down here. Okay, and now for the missing sides. Okay, so for your missing sides, again, you're going to do Pythagorean theorem. So you have a squared plus b squared equals c squared. C is the hypotenuse, which is across from the right angle. In this case, c is going to be 1. A and b are the same thing. They're both x. So we have x squared plus x squared equals 1 squared is 1. X squared plus x squared, they're like terms, gives you 2x squared equals 1. And then you solve. So divide both sides by 2. So x squared equals 1/2. Take the square root. So x is equal to the square root of 1 is 1 divided by the square root of 2. Just like before, though, you can't have a square root in the denominator. So you multiply the top and the bottom by whatever the square root is. In this case, the square root of 2. 1 times the square root of 2 is the square root of 2 over rad 2 times rad 2. The radicals cancel out, is 2. So both of these x's over here are rad 2 over 2. Okay, so let's talk about sine, cosine, and tangent of 45. It's a lot easier than the 30 and the 61. That one's tough. 45 is a little bit better, okay? So if I highlight, doesn't matter which one you're looking at, but let's say I'm looking at angle B. Angle B is 45 degrees. So the sine of 45 degrees is opposite, so rad 2 over 2, over the hypotenuse, which is 1. Anything divided by 1 is itself, so the sine of 45 degrees is rad 2 over 2. Cosine of 45 degrees. Cosine is adjacent over hypotenuse. Adjacent to that angle is also rad 2 over 2. Divided by the hypotenuse is 1. So the cosine of 45 degrees is also rad 2 over 2. And then tangent of 45 degrees, ready for this one? Super easy, is opposite, which would be rad 2 over 2, over adjacent, rad 2 over 2. Whenever you're dividing something by itself, it cancels out to be 1. Okay, so this is the other chart that I want you to know, along with the one that you did for homework with the quadrantal angles of 0, 90, 180, 270, 360. Okay, so what you can do, because if you type this into your calculator, if you type the sine of 45 degrees into your calculator, it's not going to tell you rad 2 over 2. And the reason why is because that's an irrational number. Okay, anything that has a radical in it, the calculator is not going to give you that answer. It's going to give you that number as a decimal. So here's what you can do. I even tell my A2 kids to do this. If you memorize what the decimal is, I just have them memorize the first 4 numbers. If you memorize the decimal, then you can get around not knowing what it is on your own, type of thing, okay? So the square root of 3 over 2, if you type this into your calculator, you're going to get 0.8660. What does this mean? This means if I'm ever asking you to evaluate, so for example, if I ask you for the sine of 60 degrees, the calculator is going to, you type in sine 60 degrees, the calculator is going to give you 0.8660 blah, blah, blah. You have to memorize that decimal as being the square root of 3 over 2. Or you can just memorize that's what it is, that the sine of 60 is rad 3 over 2 without typing that into your calculator, okay? The square root of 2 over 2 is 0.7071. The square root of 3 over 3 is 0.5773. You can do these on your own. You could type into the calculator radical 3 divided by 3, and it's going to give you 0.5773. And then last one, the square root of 3 is 1.7320. Okay? So again, these are options. You can either memorize the charts, or you can memorize the decimals. That way when you plug it into the calculator, you know what it's supposed to be. Obviously, like for example, the tangent of 45, you can type that into the calculator and that's just going to give you 1. So that there's no decimal for you to memorize. Same thing with a half. You know a half is 0.5, so you don't have to memorize any crazy decimal with that. It's the ones that have the square roots in them because that makes your number irrational. Okay? Your homework tomorrow is going to be to fill in a chart that has everything you did the other day, 0, 90, 180, 270, 360, as well as 30, 60, and 45. So you're going to use the videos, use the charts that are in the videos, and you're pretty much just copying that down, okay? Let me know if you have any questions. Have a great day.